In this video, we are going to be working with literal equations. Now, you may not remember what literal equations are from Algebra 1, so I thought we would review just what that terminology means. And I have here on the screen several gas laws from chemistry. So what happens, let's look at Boyle's law here for an example. You notice that this has quite a lot of variables in it, very few numbers, quite a lot of variables. And if I wanted to solve this for P2 for some reason, let's suppose I know the first pressure and volume and the second volume, but I need to know the second pressure, then I could solve this for P sub 2. This is what we would call a literal equation. It's made up of like a formula. And if I want to get either one of the variables, like in these cases, or a different variable than is currently solved for, then I rearrange the letters to come up with a different way of looking at the equation. And that's what we're going to be practicing on in this video. Okay, let's look at this one. So here I have the formula P equals 2 times L plus W. Well, that's the formula for the perimeter of a rectangle. So sometimes all the sides in a rectangle are the same, sometimes they're not, but we do know that the sides opposite each other are the same length. So if I add up the length of this one and then multiply by 2, I automatically get these two, and that gives me the whole perimeter. So in this case, it says I want to solve for L. Now, when you're solving a literal equation, they always have to tell you what to solve for because you could be solving for any of the variables that are there. You have no way of knowing until they tell you. So in this one, they want us to solve for L, which is here. So we actually have two different ways we could do this, and I'm going to do both of them so you can see what would happen. The first way, and the way that I would probably recommend, is to distribute the 2. So I would get P equals 2L plus 2W. All right, my goal is to get L by itself. L is the variable that we're focusing on. So I need to move 2W to the other side. Those cancel out. And I can see P and W are not like terms. Those are not the same variable. So I can't actually put them together. I'm just going to write them both on the left-hand side of this equation. So I get P minus 2W equals 2L. All right, still working to get L by itself. That means I need to move the 2. So I'm going to divide by 2 on both sides. Those 2's are going to cancel. All right, and I'll write my answer down here at the bottom of the screen. P minus 2W over 2 equals L. I have solved this equation for L. Okay, so now let's look at doing this a different way so that you guys can see both ways. So I'm going to erase what we've got here. And a lot of times in these problems, you have some options, and it doesn't matter to me which option you pick as long as what you do is mathematically appropriate. It's good. And I'll change colors so that we can keep up with what we're doing. All right, so I've got my red on. All right, now, parentheses, you remember, mean multiply. So that's 2 times the quantity L plus W. So the inverse of multiply is divide. Let's go ahead and divide both sides by 2. Now, the reason I don't recommend this method is because sometimes people get confused about exactly what they should divide by 2, and they end up dividing by 2 too many times. But that 2 on the outside goes with the whole side, so just dividing by 2 one time is sufficient. So I'm going to get P over 2 equals L plus W. All right, remember my goal is to get L by itself, so I'll subtract W from both sides. And what I'm left with, P over 2 minus W equals L. All right, I have solved for L. I have completed the problem. But wait a minute. When I solve for L, I got 2 different answers. If I'm solving the same equation, shouldn't I get the same answer no matter which way I do it? Okay, so let's analyze that a little bit. If I take that first equation, and let's suppose I want to simplify the left-hand side. I want to combine those into one fraction. Well, that means I'm going to need to find a common denominator. W's understood to be over 1 right now, right? You remember W and W over 1 are the same thing. So I will multiply W by 2 over 2. All right, now I have a common denominator. Now I can put them together, but they're not like terms. That just means I can put them in the same numerator. And look, I get what I got in blue to start with. So those are the same, it's just two different forms of the same thing. So the reason why I wanted to bring this up is because you guys are going to be taking SAT, ACT coming up pretty soon. It's a standardized test, it's multiple choice. I can't tell you whether they're going to choose to put this answer as an answer choice or whether they're going to choose to put this answer as an answer. So if you do all your work, SAT or ACT, and you get the blue answer and they have the red answer written on the paper, you need to recognize that those are the same thing. And the other way is true also. If you do your work and you get the red answer, but they have the blue answer written on the test, you need to understand that those are the same things also. So make sure that as you are working, you can think flexibly about these and you understand different ways of writing the same thing. All right, let's do another one. Let's look at this one. Volume equals 1/3 pi r squared h. Well, that would be the volume of a cone. So the way it's written right now, it would be like if you knew the radius of the cone up here at the top, and you knew the height of the cone right here, and you wanted to know how much ice cream could fit inside your cone. But suppose you have a different sort of problem. You know how much you want to go inside, and you know what the radius is you have to have. You want to know how long to make the cone. How high should it be? So we're solving in this case for h. Okay, let's see what we can do here. So for this one, the best thing to do is to get rid of the fraction first. If you do not choose to get rid of the fraction first, you're going to end up with a complex fraction, and those are very hard to simplify. So much easier just to eliminate the fraction to start with. So to eliminate the fraction, I multiply by the denominator. Remember, we practiced this during our warm-up yesterday. So I'll multiply by 3 on both sides. These 3's will cancel out. So 3v equals pi r squared h. Okay, my goal here is to get h by itself. So I need to get rid of the pi, and I also need to get rid of the r squared. But look, pi and r squared and h, those are all multiplied together. So I can do my division in one step. I can divide by pi r squared all at the same time. All right, the pi's will cancel out, the r squareds will cancel out. So 3v over pi r squared equals h. So there's my rearranged formula. There's the solution to my literal equation. I have gotten h by itself. All right, let's look at a couple word problems. These are going to be similar to the equations that we did yesterday. We just need to practice a little bit with word problems. Okay, so let's read that one. I'll give you a minute. Okay, so word problems for some people are difficult. Let's pause and analyze what we have here. The question that it's really asking is down here. How many hours? So we probably want our variable to equal hours because that's going to help us answer the question. Okay, so let's see what we've got. In the first job, you know how many hours you're working, so that must not be the question. In the second job, that's where it says you can work as many hours as you want. We don't know how many hours you're going to work in the second job. In the first job, you know exactly how much money you're going to make. You're going to make 28 hours per week, and you're going to make $7.25 an hour. Well, if you know how many hours you're going to work, and you know how much money you make for each hour, we can just multiply those together. And that will tell us how much total money that you're going to make. Now, in our second job, you're going to make $6.50 an hour. Well, how many hours are going to work on the second job? Well, that's H. We don't know. And I know I want to earn $255 per week. Maybe I have a car payment to make. Maybe I have some insurance money I need to pay, but I know I need to make $255 a week. Well, to figure out the total that you're going to make between job 1 and job 2, you're going to add those together and you're going to set it equal to 255. The main thing for you guys to do with word problems is just slow down, analyze what you have, and take your time. Okay, let's see what we need to do to solve this equation. Well, we can simplify on the left-hand side. So I have already typed 7.25 times 28 into my calculator, and I got 203. All right, so that helps us simplify. Well, now what will we do? How can we work to get h by itself? We're going to subtract 203 from both sides. You can see how this is similar to the equations that we did yesterday. All right, and I got 52. Okay, so now let's divide both sides by 6.5, because 6.50 and 6.5 are the same thing. That'll just save us a little bit in the calculator. And I'm out of space, so I'll come write my answer over here. And the answer to that is 8. I can work 8 hours, or I need to work 8 hours at my second job if I want to earn $255 per week. All right, let's try another word problem. This time we have gotten ourselves into a car accident. Okay, read this and let's work it together. Okay, so look at the question at the end. See if you can figure out what would be a good idea to let our variable equal. Did you pick H for hours? Then you picked the right thing. The question is, how many hours did the repair work take? So if we let our variable be that, it will help us to answer the question. Okay, let's see what happens. I know the total bill, I know the parts, and I can figure out the labor. So if I add the parts and the labor together, that's going to give me the total bill. All right, let's see what I've got. The total bill equals parts plus labor. All right, and I know the labor is $35 per hour, but I don't know how many hours they had to work on my car. That's going to be H. I'll take the $35 that they earn every hour, and I'll multiply that times H, which is the number of hours that they have worked. Okay, so how will I solve this? Trying to get H by itself. First step, subtract 2,796 from both sides. Right, those are going to cancel out. You can type that in your calculator if you want to, or you can just work it out. Either way, you're going to get an answer of 699. All right, so now let's divide both sides by 35, working to get H by itself. And I got 19.9714, a lot of stuff. All right, so you'll have to read the directions for this kind very carefully. It's possible to work for a portion of an hour. So the directions might say to round to the nearest hour. If that's true, that means to round to the ones place. So the 9 makes the 9 go up to a 10, which is going to make my 1 go up to a 2. So it took the repair work about 20 hours. They might say to round to the hundredths place. Here's the hundredths place right here. If they say that, 1 tells the 7 to stay the same, and you get 19.97 hours. Be really careful to watch, especially in Delta Math, watch what place value they want you to round to. The computer doesn't know how to be gracious. It doesn't know that 20 hours and 19.97 hours came from the same number. If it asks you to round to one of them and you round to the other one, it's going to mark it wrong. So be really careful about what place value you round to when you do these in Delta Math.